Welcome back to my lecture on economics of public policy. In our last lecture, we discussed about Harrod-Domar model, where we discussed how economic growth is related to savings rate and capital output ratio, and also depreciation cost. And then let's move on to the next. In sum, what Harrod-Domar said, Harrod-Domar model emphasized on the savings rate. As we already discussed, like you save more, then economic growth will be there. So increasing the savings rate will lead to the rise in the economic output and eventually economic growth. However, what was not convincing, or what was the policy concern, was it encourages low income countries where per capita income is low, including India, for external borrowing from international lending institutions like Asian Development Bank, the World Bank, and the International Monetary Fund. The main issue is with this approach is the problem of the repayment, and that was a major concern, and that was somehow was not discussed, or was not the kind of policy solution from the Harrod-Domar. And Harrod-Domar, as we discussed, like Harrod-Domar model is a simple model and linear model which did not capture a lot of nuances, and it is not a dynamic model which actually can emphasize on the total overall production. Many models, growth models, are also there to address some of the policy concerns, and this is not the course where we'll be discussing about all the growth models of economics. So what our objective is to give you the broad discussions around growth, and public in context of public policy. And what we know from Harrod-Domar, that Harrod-Domar is developed on the Keynesian model, and therefore Harrod-Domar is also regarded as a Neo-Keynesian growth model. But here Solow model is based on the Neoclassical, Neoclassical model. And in Neoclassical framework, based on the Neoclassical framework, mainly production function, Robert Merton Solow developed growth model where the impact on the growth of savings, population growth, and technology were concerned within the closed economy, without government sector. So here, like Harrod-Domar, Solow's model also is limited to the closed sector, or we can say closed economy. But here in Solow model, in the production function, technological progress is concerned, and also taken into account, and also population growth, unlike Harrod-Domar model. So Solow model, based on this neoclassical, based on the neoclassical production function, Solow growth model is also widely used, and later Solow also received Nobel Prize in 1987. So let's go ahead with what are the assumptions, basic assumptions that Solow considered. So there are broad, we have kept only broad assumptions. The first assumption is the economy consists of one sector producing one type of commodity that can be used for either investment or the consumption purpose. So that is the first assumption. So it is like one commodity at a time. Economy is closed, and therefore international transactions and also government interventions is not taken into account. All output that is saved is invested. Like this is also kind of Harrod-Domar's assumption, like all savings needs to be invested, and savings is basically taken place by the households, and then in the financial institutions, and then financial institutions actually will facilitate the investment. Therefore whatever the savings will be there, so that needs to be invested or equivalent. The fourth objective of Solow model is full price flexibility and monetary neutrality, which means that economy will use its full capacity or the resources for its total level of output. Um, Now the fifth assumption, where Solow actually abandons all the assumptions of Harrod-Domar on fixed capital output ratio as well as fixed capital labor ratio. So in Harrod-Domar, what we had seen, like capital output ratios like small v was fixed, and capital labor K by L ratio also was fixed. But in Solow model did not consider this to rigid or fixed objectives. Um, and then rate of technological progress, population growth, and the depreciation rate of the capital stock all are determined exogenously. So these are the broad 6 assumptions that Solow model considered. Uh, Now let's move to Solow model with some basic, equations, and also we also will talk about with the help of some visual effects, like say with the graphical interpretations. So when we say that, before that, let's also have some fundamental assumptions in the Solow model, and then we'll discuss like how Solow model and Solow production function is different than the production function that Harrod-Domar considered. So here capital Y, which is output, total output is a function of K and L, and here is capital and labor. And for all values of K or L, assumption is K and L both will be positive, and therefore production function will be capital Y equals to capital F of L and K. This exhibits the positive, but at the same time, as all of you know, that this is the assumption of the diminishing marginal returns with respect to both capital and labor. So what does that mean, and which are the assumptions? Like first order condition, first order condition for production function with respect to capital will be greater than 0, but then second order conditions will be less than 0, like df by d delta k, which means marginal productivity of capital, and df by dl means marginal productivity of labor. Both will be positive, but then slope of marginal productivity of capital, which is d2f and dk2, means second order condition, will be less than 0, and d2f by dl2 will be less than 0. So this is basically the diminishing marginal returns assumptions with regard to labor and capital. So and second assumption is like unlike Harrod-Domar, Solow model considers constant returns to scale, which means like if inputs like K and L are increased by lambda times, then output say F or Y, capital Y, also will be increased by lambda times. Lambda could be any value, like if in the production function, if labor and capital are increased by 2 units, then output also will be increased by 2 units. So here lambda is 2. So this is the assumption which exhibits the constant returns to scale. Solow considers effectiveness, like output per worker and also capital per worker, like small y and small k. So small y is basically total output upon total labor force, and here is, one can actually consider as a average productivity of labor is basically it is not all the labor will be considered, it is basically output per worker. So here already marginal and average productivities concept like is coming, and k, total k is a total capital stock, but small k is like how each worker is actually dealing with the capital stock, is like total capital per workers. So this is the assumption. that Solow considers, and therefore Solow production function will vary what overall production function that we consider, like from the first one, like y equals to f function of capital and labor. If I say that is equation 1, then Solow equation is referred as that small y equals to fk. So I'll just tell you how we have arrived to this. If y equals to f by k upon L, and then if we and Solow considers worker, capital per worker and also output per worker. So capital Y by L, and then F will become K by L, and then this is 1. So one can write small y. I mean, small y is basically nothing, is output per worker, like small y equals to function, like we are trying to give the different denotation, which is small f as a functional it shows the functional relationship, and then here small k is basically total capital, but then capital per worker, and then this is the equation that Solow used it in the in order to define the production function. So here production function, this is the Solow production function, again following diminishing returns, like first order condition will be greater than 0, and second order conditions will be less than 0 for all k. Here small k only used. So here production function, labor is used, but then labor as output per worker and capital as a capital per worker. So labor is embedded to output and also embedded to the capital in order to understand its effectiveness. That is the major assumptions that Solow considered while framing the Solow model. So as the capital, what does that mean? It's like as capital output ratio approaches to infinity, the marginal productivity of capital approaches to 0, and also as capital output ratio approaches to 0, then marginal productivity of capital will be infinity. So now let's see how production function in a graphical form, how it looks like. As diminishing marginal returns assumption follows, so production function will be like similar to other production function, but here on the vertical axis we consider small y, which is capital Y by L. On the horizontal axis is small k, which is nothing, is capital K by L, and here 0, and production function, which is this is nothing, capital per worker is a function of like K by L and L by L. So this is how, and then this is how the total Solow production function looks like. So now let's move to the model, and then Solow model also derives from the capital accumulation equation, what we already discussed in the Harrod-Domar model. Capital stock, it depends on the investment in the last year, like capital T, like Tth, if T plus 1 is a present, and then 1 minus delta time of total capital stock of the initial year, like T. And this equation is familiar because we already used it and also discussed how it came in context of Harrod-Domar model. So Solow also depends on that. But here Solow also assumes as one of the assumptions, like whatever the savings will be, that needs to be invested, like the same assumption where this is equilibrium condition, where investment equals to savings, and as we know saving is a function of output, and this is small is the rate of savings. So savings will be at the rate of S times of total output, because savings is positively related to or proportionate to total output. Because savings, I'm reiterating that savings only happens after the consumption. So saving is basically the leftover. So we have put the value of savings in place of investment following the equilibrium conditions, and then rest remains the same. Then we have to convert the total function, like if I give this as equation 1 and this equation 2, then equation 2, from equation 2 will convert the capital and output in terms of capital and output per workers, because that is the Solow's assumptions, and we'll convert this equation in the Solow's in form of Solow's production function. And therefore kt plus 1 by L, here L is, you can write LT plus 1, and here we can write LT, and here also we can write LT, is basically KT plus 1 by LT plus 1 equals to small s YT by LT plus 1 minus delta. Delta is depreciations, KT by LT. So this is nothing, is we can write in this way, and this is just expansion, and here I'll just expand from the previous equation, like KT plus 1 by LT minus from here KT by LT. So here we have taken K by L, KT by LT in our left hand side, and on the right hand side it remains like SYT by L minus like the second part of the of this portion, like delta times, so delta times KT by L. So this is what. So one can write like this is nothing, like this, just one more expansions from here. This is nothing like small kt plus 1, and this one minus small kt, and here is like small s small y, because yt by lt is nothing, is basically output per labor, and minus delta small kt, and here also I can write small t. So, and this small kt plus 1 minus small kt is nothing, is basically changes in the total capital per worker ratio, right? So is basically it is coming from changes in capital labor ratio, right? And which is capital per worker, and so this is what one this is what we get the Solow's model. So now with the population growth, so here we can write is equation say 3, and with the population growth, like depreciations, we will not discuss much because we already discussed in context of Harrod-Domar how population growth will come if population growth rate is small n, then small n times of small k will be added here. So this is like Solow's growth equations considering depreciations and also the population growth rate of n. So so changes in the capital per worker, so delta small k depends on the population growth and also depreciations, as I said, but then also it depends on savings rate and total output per workers. So Solow model certainly is the modification of Harrod-Domar, but then it is not as simple as like Harrod-Domar, because it is a dynamic model, because production function is dynamic, and because it depends, and it is non-linear because of diminishing returns to capital assumption. So just a graphical interpretation of Solow model. Here one can say like this is panel 1 and this is say panel 2. In panel 1 On the horizontal axis, if we consider small k, which is capital K by L, and on the vertical axis small y, which is capital Y by L, like output per workers, and then here the state, and this is the origin is 0, and then this straight line represents n and n plus delta time of small k, because n and delta both are increasing, and these coefficients are constant, and therefore this is like linearly it will be increasing with the output per worker and also capital per worker, and therefore this is a straight line from the origin. Here there are two functions, nonlinear functions are introduced. One is savings function, which is like first half of the first part of the equation 4 here on the right hand side, like from the Solow growth model, like small s f k. One can also write as like small s y. So y is nothing, is small y is nothing, is basically the production function where it considers function of capital per worker. So here this is the savings rate, and then of course total output will be in proportionate to the savings, and therefore this is the Solow production function, this production function like small f k. So now you can see here like at point A where small sfk is intersecting with n plus delta k, like here if we look at the equation 4, you can see like on the right hand side of the Solow equation, where small sfk is equals to small n plus delta k. So they are actually here at point A, at k star amount of capital stock, like capital per worker stock is basically changing here, right? I mean here they are equating to each other. So across this, if in this condition where delta k is equals to 0, in this particular context delta k at k star, here delta small k is equals to 0. So at delta small k equals to 0, here the output y star, like is a e. So at this level where savings and n plus delta k, where they are equals to each other, at that level y star amount of output will be generated in the economy with the OK star amount of the capital per worker per worker. So in panel 2, on the horizontal axis, the same indicator small k, and small k is capital per worker, and on the vertical axis it is like change in the capital per worker, like small delta small k. So in this at k star, where at small k star where delta k is equals to 0, but on the left hand side delta k is greater than 0, and beyond k star delta small k is less than 0, more than 0 and delta k is less than 0. In these three possibilities, how capital stock function looks like, so it will be increasing, and then it is actually 0, and then it is decreasing. So this is how in two panels one can see that how capital stock and capital per worker, or one can say that changes in the capital per worker, and then how it is related to the total production. So now let's interpret this equation much more a bit of in details. Like say this is a Solow growth function where delta small k is equals to small sy. Small y is basically nothing, is basically small f k minus nk minus delta k. So small n is the population growth rate, and delta is depreciation. So now What does that mean? It means like delta K is positively related to savings per workers. Therefore, this means investment per worker and capital stock per worker will increase. Then delta K is negatively related to population growth by minus NK amount, which means with the total, with the growth in the production and the labor, there is an increase of minus NK amount of new workers. If there is no new investment or fixed investment, increase in labor will lead to decrease in the capital stock per worker. So that is why K is negatively related to capital changes in the capital per worker. And depreciation rate like small delta erodes the capital stock by minus delta K. So this also defines stationary state situation of the Solow. Therefore, savings and investment adds to the capital per worker, where labor force and the depreciations are negatively related to total capital stock, which means labor and population growth rate, they reduce the capital per worker. Now let's move to the other three possibilities that we can discuss to interpret Solow model more. So in the graphical representations, we discussed how savings rate and N plus delta times K, how they will be related when delta small k equals to 0, delta small k is greater than 0, and delta small k is less than 0. But in this slide, we will discuss these three possibilities. When savings rate, savings per workers is higher than N plus delta k times delta times of k, which means if savings per worker is increasing or increasing more than N plus delta k, then delta k change in the capital per worker will be more than 0, which means capital deepening, which also, in other words, we can say that enhancing labor productivity. It means labor will have more physical capital to access, and that will actually have the impact on the production. The second is small sy is equals to N plus delta times of small k, which means there is no change in the capital, change in the capital per worker ratio like delta k. So delta k also will be equals to 0, which means capital widening. Means the way savings rate will also will increase, population rate and depreciation combining them, these two also will be increasing at the same rate. The other is possibility when delta k will be less than 0, when small s, like savings per output will be less than N plus delta k. So this is the three possibilities in the Solow model. I hope you understood this Solow growth model. I'll stop here. And in this Solow model, I have also used Brain Snowden and Howard Arvin's book on modern macroeconomics, chapter 11, where you can also see Harrod-Domar. So I thank you very much for your attentions, and I'll see you in my next lecture.